Here we have a normal distribution for which we know neither the mean nor the standard deviation. So we just write that x is a normal distribution with mean mu and variance sigma squared. We do know some information pertaining to areas, however. Using this area first, since it's the easiest to work with, we know the probability that x is less than 2.9 is equal to 1 take away 0.0918. Remember, the total area under the normal curve is 1, so if we know the area to the right is 0.0918, then the area to the left, the less than 2.9, must be 1 take away 0.0918. And this is 0.9082. Transforming to z, we get z is less than 2.9 take away mu divided by sigma is equal to 0.9082. Once again, we know the phi value, but not the z value. So when we look up tables, we look for the probability 0.9082. If we do so, we find that phi of 1.33 is 0.9082. Comparing the last two lines, we know that 2.9 take away mu divided by sigma is 1.33, or 2.9 take away mu is 1.33 times sigma. Let's call this equation 1. Now let's start to work with the other area. We can use the symmetric nature of the curve. What we need is this symmetric point to the 2.5. We then know this area is 0.1527. This area to the left then is 0.8473. We need this value. The distance here would be mu take away 2.5. The symmetric point will be the same distance to the right of mu, so must be at the point 2 mu take away 2.5. To go mu minus 2.5 to the right of mu, we do mu plus mu minus 2.5. If you don't understand this, just try it with a few numbers. The probability that x is less than 2 mu minus 2.5 we know is the 0.8473. Transforming, this gives us the probability that z is less than 2 mu minus 2.5 take away mu divided by sigma is 0.8473, and simplifying, the probability that z is less than mu minus 2.5 divided by sigma must be equal to 0.8473. We need to find 0.8473 as a phi value in our tables. I'm using a set of Edexcel tables which give z values to 2 decimal places. I can't actually find 0.8473, but what I can find is that phi of 1.02 is 0.8461, and that phi of 1.03 is equal to 0.8485. This value is exactly halfway between. We can therefore assume that phi of 1.025 is 0.8473. But in practice, in most exams, you wouldn't be expected to do this. You could just use Z is 1.02 or Z is 1.03 with no loss of marks. However, using this interpolated value, it follows that mu minus 2.5 over sigma is equal to 1.025. So mu minus 2.5 is 1.025 sigma, and we'll call this equation 2. Here we have the two simultaneous equations. If we add the simultaneous equations, 1 plus 2, the mu's will cancel, and on this side we get 0.4, and adding these two gives me 2.355 sigma. So sigma is 0.4 divided by 2.355, and this gives us 0.16985 and so on, or 0.170, correct to 3 significant figures. To find mu, substitute this value back into 2, and we get mu is 2.5 plus 1.025 times 0.16985 and so on, and this gives us 2.67, correct to 3 significant figures.